So hello again. We're picking up right where we left off yesterday. We're discussing casting up and casting down within this hierarchy that is um, generated by our is-a relationship that we have between reference types. We said that when you're casting up, then you can use an implicit cast because any subtype is of its supertypes as well. However, when we're casting down, a supertype, the object stored within a variable of a particular supertype may be of any subtype, and so we have to do an explicit cast. We noted that there can be an issue with this because what if it isn't actually of an instance of that type that we're trying to cast to? That'll throw an error, so we should check first, is it actually an instance of this type? If so, then we can cast to that particular type and store in a variable of that subtype. All right, so this is just an example of that. Then casting with interfaces. We said that an interface is this description of the behavior of any type that implements that interface. We can declare variables of that type, but we cannot instantiate them. We cannot create objects of that type. However, we haven't yet actually created ones that implement it. So we can create variables of that type and work with them. However, when we actually create a particular subtype, we will then have to cast to that particular type. All right, so here we have an interface person. We have a type student that actually implements person, which means that it at the very least has to have the method equal to that is described in that interface. It does indeed implement that. It will accept any variable of type person. So any other class that actually implements person will be able to send an instance of that class as an argument to this particular method. However, we need to cast it to student, and so we should actually check that is indeed student. We have here, so you can instantiate a class within itself. Yes, you can. Right? In fact, for all our like comparators, we want to be able to compare one type or rather one object to another object of that particular type. I will have to be able to instantiate that and describe how that comparison is done. Interestingly enough, that is in the prac, but I wasn't quite sure whether you guys have done that or not. So I give you that code, but you will see an example of that in the prac today. All right, and generic, something else that I'm certain that you have covered. So we understand that the highest type in our hierarchy in Java is the object type, and all other types are subtypes of that. Well, generics allow us to be able to use with to be able to work with undeclared type, but in a more elegant way that allows us to create reusable code. So we don't declare what types we're gonna work with, although we can actually restrict it. We can create a bound on what types we will accept. However, we say we don't know what the type is going to be yet, but we can create an object that has this particular type, perhaps type T, or here we're creating a pair that has type K and V, and we can describe some methods on that pair. Understanding that when Java actually then, when our compiler actually compiles this, those type parameters will be replaced with either object, or if we've created a bound on it, with that bounding type. Right, but we're able to describe code, create code that does not restrict our parameters to a particular type. All right. For the first prac, we do use it a little bit, but I don't expect you to actually work with it. However, if you have forgotten what you learned in generics, regarding generics, you really should go and relearn that, because in almost all the next pracs, you will be expected to use generics within your classes, so that your classes are more generalized and can be able to be reused regardless of what particular types we're working with. Okay, and by convention, we usually use a single uppercase letter to represent this unknown or yet undeclared type. All right, and here when we actually instantiate an object of type pair, then we will have to pass what those particular types are. There was no bound on our types. If you'll see, we simply had K and V. We didn't say that it extends a particular type, so it wasn't bounded. So any references can be sent to that, or any types can be used to instantiate an object of this pair. Here we use a string and an array list. All right, so not defined at compile time, they're specified at runtime. An instance of this will then actually have some type parameters. As I said, they can also be restricted. Some texts will use the term bounded by saying, okay, any types K and V, any types K and V, but V has to extend array list. So now it would have to be either an array list or something that extends array list, whereas K can still be anything. So here, one of my parameters is bounded. All right, and that's it for our refresher. Again, there are some reinforcement exercises that are in the text. Those are given here. We have a question. Can you use generics inside a graph ADT? Yes, and we definitely will. We will not say what type of element will be stored in our nodes within our graphs. We want to be really general. We want to be able to work with any types. And so we'll almost always in our ADTs use generics, and then only when we actually work with them within some controlling class, where we say, all right, we're actually going to create objects of these particular types, but we'll be able to use all our code as long as we make sure that sometimes we have to bound them. For example, if we're going to be doing comparisons of objects, we have to make sure that those objects are comparable, and so we will bound those. But yes, we will almost always use generics. All right. So what you've all been waiting for, the practice. Okay, so today is your first practical assignment. I have tried to go easy on you. The task is not actually to do this quickly or a race in any way. It's really to try and get you back in the groove of problem solving using Java and all the design principles that we discussed. We talked about the 40-20-40 rule, that when you're designing a program, you spend some time on design. In fact, 40% of it on design. Your coding implementation should be 20, and your testing and debugging should be the other 40. And so that procedure of taking a problem, decomposing into classes that will do the work, and then actually writing some pseudocode, implementing that, and then testing and debugging it, want to get you back in the swing of that. So I'm giving you source files that have most of the methods already filled in. You're going to go ahead and, given a description of what each method should do, implement it. All right, already have a question. Is it okay if we use Java 8? Yes, asked and answered, you may. So does it mean that we should submit some sort of design as well? No, right? We spent years hammering that into you. You don't have to submit it, but of course you should be using it for your own understanding. Okay, almost always when we're doing this in person, when someone asks me a question, I would ask them, okay, where's your design? They would then hastily scribble that down. And in doing that, the answer would come to them. So oftentimes it's simply that our brains, if you think our RAM is quite limited, the things that we can compute at the same time to be able to synthesize the ideas that we're trying to work with is quite limited. So when you put that down, it allows you to be able to take the next step and synthesize those things that you've written down. Okay, and also we think in pictures, not words. So by creating those graphics, by creating those class UML diagrams, and then describing what those methods should be, it helps to get you a little further than just trying to think of everything at one time. All right, obviously in future, we'll give you slightly larger tasks where you are going to decide what the methods should be, but then we'll also be working with implementations of ADTs, so you will have an interface and you'll be having to implement the methods described by those interfaces. All right, so rules for every practical that you're going to do. Make sure to read the question. The questions that I get oftentimes are within the question documentation that you get. make sure you read it once, twice, fully understand it, then go ahead and attempt it. There's a question, is the recorded sessions downloadable? Yes, they are. They're available almost immediately after every class, right? Blackboard, once we exit, stop the recording, it takes a couple minutes to process it, and then it's available. If you don't know where to look for it, just go and look in the general channel on Discord. I did put some screenshots there of where you have to click to access the recordings. So read the question, very important. Make use of files, provide an additional files for testing your code. In this case, we're going to have source files as well as some files for testing your code. Please, you have to upload before 5:30 on Eve, so you will have just over 4 hours to be able to do this. And remember, you have to include Java doc, documentation, and executable jar file for this one. So how to run jar files, because my PC does not run the jar file, please help. I will show you, all right? Executable jar, yes. As I said, I will show you how to do that just now. All right. Okay, don't focus on that. That's the least of what you have to do, and I'm gonna show you exactly how to do it. The point is just to get you in the habit of doing it, because you will have to do it for your project. When you give code away, you will very rarely be given your source code when you've created an application for someone to use. A jar file is then this platform independent file that I can go and execute on any machine that has JRE, or as long as I package all my necessary code together properly, I can go run it on any other machine. It's very useful. Yes, it has been shown that people can actually figure out the source code was given a jar file with some effort, but it is a nicer way to share code rather than just giving source code. Right, so what is the question? Well, you already know that you're going to be working with blockchain this year for your mini project. So we're going to have some practicals based on ciphers and encryption in general. And as I said, looking at ideas that are kind of behind the workings of systems like blockchain, looking at ciphers. Okay, I won't say more than that because we'll have a couple of tracks that actually do specific things within that. But here we're going for the simplest thing we can do before we even talked about the ADTs that get used in more complex types of ciphers. So we're going to look at one of the most simple ciphers, which is called the substitution cipher. You have your alphabet A to Z. You then decide on a substitution for each letter. So you can think of it as a permutation, a rearranging of the letters of that alphabet, so that now each letter from our normal English alphabet is mapped onto another letter from that alphabet, but in a different organization, in a different sequence. So here we have a random one, A, B, C, D is our normal one. That is mapped onto D, G, I, X, Q, K, there's a dot, dot, dot there, to all 26 letters. So if we had a document in plain text, so just a text file with human readable text, we would then go to every A and replace it with a D. Go to every B in our text, replace it with a G. Every C with an I, every E with an X, every F with a Q. Right? Did I miss one there? A to D, B to G, C to I, D to X, E to Q, and F to K, and so forth. Right? What I end up with? Text that you can't read, but in a very simple way. I define this cipher that is simply a mapping from letters in my normal English alphabet to a permutation of those letters, a rearrangement, a different sequence of those letters, so that each one gets mapped onto not necessarily a different one, but just one in this reordered. Yes, they have to be unique, they're distinct from one another, but you may find that one letter is mapped onto itself. There's some really simple ones where you simply shift them by a certain number of fixed characters. So you can shift all your letters by one. So A will map to B, B to C, D to E, E to F. But that's really simple. So usually they'll map it onto that character plus 7, plus 8, plus whatever. The point is you end up with text that you can't read, and someone would have to know what exactly was the shift that you decided, or in this case, the random permutation that you chose to map those normal English letters onto a rearranged sequence of those letters. All right. So do we just randomly map the letters? No, you're not even going to be doing that. You're going to be trying to figure out, how can we decrypt this? Given the ciphertext, so plain text that has been substituted with this reordering, how do we then figure out, well, what was the original text? And this is what we can use. We know that there are certain letter frequencies, right? The letters in the English language occur with a different frequency, and their relative frequency is pretty much fixed, right? Apparently, E comes up the most, then T, then A. So if you substituted E for, let's say, Y, then if I analyze my text, all of a sudden, Y is going to come up the most. So I know, oh, that means that E was replaced with Y. And if now Q happens to be the second most frequent item, I know that Q was initially T. So just looking at relative frequencies just means I count up the occurrences and I divide each one by the sum. So if there are 10 letters, 2 A's, 1 B, the frequency for A would be 0.2, the frequency for B would be 0.1. It's simply a ratio of how many times it happened over the sum of all the letters. We'd need to have a lot of scrambled data though. Yes, excellent point there. And you will actually see that because you don't exactly have enough time to come up with the most elegant of algorithms, though you may well, you're more likely to simply go for a brute force approach. And that, to execute in a decent amount of time, you really don't want to work on more than a few hundred lines of text. And so, yes, it isn't quite enough to get a really good idea of the frequency. So even the text that I've given you, I simply took a text from one of these NLTK corpus. So it's just some text. It doesn't work really well because it isn't a representative text. However, it just means that you have that file. You can see what you get when you try to decrypt that file. Right. What if two have equal probabilities? Yes, there's some that have very close probabilities. In fact, the analysis that's been done by different entities have found that like A and T can swap, they're pretty close. I think it was P and N. So they're not absolute, but we're going for the simplest cipher that we could do with the data structures that we have at the moment. We will see that we can do better, and we will. But for this one, we're going for simple. I assume that the frequency of each letter in the alphabet changes with time, since every language dictionary is ever growing. Yes, exactly that, right? And interestingly enough, because I looked at a couple of texts from these corpus, and what I found is that a lot of the ones that are available are things like Shakespeare, and all the works of Edgar Allan Poe, and all the speeches of the American presidents. And none of these things are actually very representative. The American presidents, because they keep saying things like America and the Middle East and things that you don't say in normal everyday text. The others, because they're quite old, right? And because usage changes over time, they are not representative of the frequencies that we would expect. Okay, excellent comment. How often does a letter occur? We'll look at that now. In everyday text, yes, it can be complicated. It takes years to crack these things. Yes, of course, especially if we're trying to use the most simple approaches, right? It would take a very long time. We'll see that we can do better, certainly. And in fact, in all coding theory, if we're talking about it, it's not always about directly trying to decipher something. It is trying to figure out what are the features, the underlying features that remain consistent, because that can be used for an approach to decipher text. And sometimes can be rather complicated, right? I don't know if you guys have done, you certainly have done 2B, you've done networking, so perhaps you discussed different types of error detection and correction codes, right? You may well have talked about Hamming codes and those, where we use additional bits to be able to detect if there have been changes. And so There are little things like that where we can see what has changed, and certainly a cipher is a type of change of a plain text, and we can use some of those approaches towards deciphering. Right, but we will discuss it as we go forward. Right now, trying to keep it simple and doable in the time that we have. So we're gonna use the known letter frequencies. You can actually calculate your own. I've given the plain text as well, and you'll see that it's quite similar to the frequencies that were given. But in any case, we'll use those known frequencies, and I've already hard-coded them for you. You will calculate the relative frequencies in the ciphertext, and then it's simply, well, if you put them in the same order, let's say ascending or descending, then you can substitute the most frequent for the most frequent. So as I said, if Y comes up most, you should replace that with E, and the second most frequent for the second most frequent. So the second most frequent in your ciphertext should be replaced with the second most frequent in usual plain English. And at the end, we'll print out the ciphertext. Right, or rather print out the original deciphered message. The toString asks you to actually print out both, which you'll see. Okay. So these are the frequencies. All right, this is straight from Wikipedia. I've given you the source there. So these are the frequencies that were found by looking at, I believe it was 40,000 words. So a text that had about 40,000 words. These are the frequencies that they found. It's noted that the frequencies aren't the exact same if you look at different texts. For example, if you look on the right there, this is them ordered by relative frequency. So taking the sum and dividing by each one, we get these percentages. I seem to have cut off E there. All right, we have E, then T, then A, and if you kind of go down a bit, you'll see that there's some like M and W that are almost the same. All right, to more significant bits, the one is greater than the other, but looking at different texts, you find they often swap. And there's some others that are very close to one another as well, G and Y, and so forth. So it's not absolute. Question, so we'll be given both the ciphertext as well as the original text. Yes, you'll see that if you get it right, at least as far as the solution that I've done, which is a brute force approach, what you get is not actually the correct original text, but you can, just for the kicks, take that original text, apply the cipher, because as soon as we find out the deciphering permutation, you actually then have the encrypting one as well. So you can look at that. But more easily or more interestingly, you can simply look at the frequencies within that original text, and you'll see that it's quite similar to what we have here, quite similar to what others have found. And so a relatively small text, right? But at least the first three, I think, were the exact same, and the others were kind of grouped into similar subsets within this. All right, so these are the tasks for the prac. You're given two classes, main and decipher and decryptor. You have to complete the main class. There's a single method where you're going to read in text from a file. You need to expect that. Then you're going to complete the missing methods in the decryptor class. It's really the constructors and then operations on strings or arrays, very similar types of operations, to be able to count up the frequencies, change those frequencies into relative frequencies by dividing. It's simply, you have an array of numbers, get the sum of the array, divide each one by that sum. That should be straightforward. And then order it by the frequency. So to be able to order characters by a frequency, I've simply defined a class for you, and that class stores a character and a frequency, and you can create an array of that, which I've already declared as an instance variable, and that allows you to be able to sort a 2D array basically on one dimension, even though they are different types. All right. Okay, yes, indeed, Hello World is fun. Do space characters count as part of the cipher test? Great question. You should be ignoring anything that isn't a lowercase character. All the text has been changed to lowercase. One of the tasks is actually to remove punctuation. Leave the spaces, but in your decipher method, just make sure that you ignore anything that is not a letter. In fact, anything that is not a lowercase letter. They all should be lowercase, so just ignore anything that is not a letter. And we have methods for that. Note, this is not for you to try and go find the best methods online to do this automatically. You should not be using external libraries. You can get this done just using Java IO and Java util. You can use the arrays library. there's really your package. There's really not much else you need. If you go out there and simply find something that can do this automatically, you will not learn anything. And more importantly, I try to find something that doesn't have solutions out there, or solutions that work for this particular case, because I know we're all very adventurous and want to go try to find the solution quickly. But looking at it method for method, it's not that difficult. All right. Certainly, if you understand it differently, and you'd like to attempt it in a different way, you can add your own methods, but you must have the methods that are required for you to complete. Do you have to write a program to remove the unwanted characters? Yes. You will have to, yes, you can use string builder. Okay, so you simply want to ignore those. Okay, yes, you can ignore them. You can store the original one, and then perhaps it's actually simpler to simply store it minus the punctuation. But if you want to ignore it when you're doing your comparisons, you can do that as well. All right, in the end, you're really having an array where you simply look for A to Z, and for each occurrence of A, you're incrementing that count. For each occurrence of B, you're incrementing that count. That gives you your frequencies. You divide by the sum to get your relative frequencies, and then you are going to order that, and that'll allow you to be able to substitute one for the other. All right, so enough talk. Let's actually see what this looks like. I'm going to have to switch to my desktop, so give me one moment. All right, so I hope you can hear me. I'm going to stop this, and I'm going to then share. Let me actually open Eclipse first, and we'll go from there. Yes, you're going to submit your source file. You're going to submit your entire project. What is the naming convention for the project? I'm more concerned with the naming convention for your file, right? The zip file that you are submitting at the end of this. All right, so give me a moment. I'd like to actually upload the prac first, so you can actually download the files yourself, and then I'll show you where we go from there. All right, so you should be able to see now on Eve that there's a practical uploaded there. And in additional files, there is a zip file there for you. Right, so perhaps I should first share the file itself so you can see what I'm talking about. All right, I'd like us to talk for about 10 more minutes. So I've extended the practical submission time to 5:40. So you'll still have a good 4 hours to get it done. Do we submit full files? Yes. Was name creation? All right, so that is the goal departure cipher text, yes. So here is a more elaborate description of what is being done. Exactly what I've discussed, that it's a simple cipher, that you are actually using a permutation as your cipher. So you have the original alphabet, you're deciding on some reordering of it, and that maps one letter onto the other. So we substitute, in this case, A with J, X with B, and so forth. That's what's already being done. You're trying to figure out, well, what were the original letters? So if this was the text, the cat is out of the bag, you'd be given this SAD, RJS, QF, so forth, and you have to figure out what was the original text. To do that, you have to figure out the relative frequencies, then simply line them up. We know that E is the most common, so whatever has the greatest frequency will replace with E. All right, as I said, the results are pretty poor because I have to use a small enough file, but this is what you can expect if you give exactly what is given there. Ciphertext is repeated for some reason. This is what your zip file name extension should be. Please make sure that you name it exactly that. And the mark sheet is pretty fine grained. All right, it's method by method, so you understand exactly what you have to do. And even when you get your marks, you'll know exactly what you did well and what you had issues with. All right, so as promised, here we are in Eclipse. This is just a fresh install. I've taken the file, zip file from Eve. I'm going to extract that now. I'm actually going to just extract it in my C drive, my root directory there. I'm going to call it key01, and then you will see the rest. File. I'm going to open a project from my file system. I'm going to choose my C drive. The file, zip file is here. I've just opened it up and I renamed it. Inside of it is simply what you expect in the project. I have force, I have data, so I have 2 directories within that. I don't think I should do anything else. I will then finish. So that creates, importantly, my top directory was just the file name itself, was this file named P01. Within that, there are no packages. It's straight source and data. This is what's in data. It's a 2 cipher text. And this is what is in source. Source doesn't have any sub directories. And so they're in the default package, as in this doesn't actually exist. It's just being shown there. And so I'm able to compile these without needing to add any package names. I have to make sure that now my file names are the same as my package names. It's important to make it easier to do it this way. If you do change names, something like that, which for this one you really should not, because you're given the classes and all the methods you should create. However, remember in Eclipse, if you're going to change the name of something, you have to refactor your code, not just change the file name, or you're going to end up with issues. All right. Yes, I will not. The only 2 things I'm doing here is showing you how to do those 2 things. All right, so the code doesn't actually work right now. It's simply because methods have been removed. All right, so let's take a look at what these errors are. Okay, anything that isn't void simply wants something to be there. I'm going to return null because that'll work for all my types. So all I'm doing here is just showing you that the code should work. Also, 2 strings should return a string. All right, I save that, it works. I have the same issue here. And I have one more issue. Decryptor, my decryptor. Okay, the constructors don't exist. I'll create the constructor within this one. It's the default one. It's one that expects a string argument. That's fine. You will actually have to add these anyway. So I'll leave that. I'll save it. And there I have something that actually works. I just wanted to be able to run, even though it's not going to do anything useful at the moment. You see that if I run this, I simply get null as my answer. I will now show you how to generate the Java doc and the jar file. Then we'll actually go ahead and look at the code with the minutes we have left. If I go to, where do I go? Project, I believe. Yes, project, generate Java doc. If I have my proper Java doc comments, which you see I do have here, I'm able to simply then select what it is I want to do. I want to create my Java doc and output it somewhere. It should be within the root directory of my project within a subdirectory called doc. Great, I'm happy with all that. And then the P01, and it's going in a folder named doc. Great. There are some other options. I'll simply use the default ones. I can click finish. Do you want to update for the total destination? Yes to all. All right, there'll probably be some errors because nothing is actually being done. All right, but note I now here have doc with all my Java doc documentation. So one more time, project, generate Java doc. That's it, right? If you're doing this in command prompt or in your terminal, it would simply be Java doc, and you give it I believe it should be the file that has your main method, yes, and then it'll do it. So you compile it just like anything else. Do I specify a naming convention for the practicals? Usually P01, P02, P03 is fine. However, it has to be that you have a folder with the directory's source data, if you have some data in there, doc for your documentation, and bin for your jar file. The doc and the bin will be created automatically when you actually create your documentation and your executable jar file. All right. It's important that we just have a folder with those subfolders so we can import that and be able to run it. Does the Java doc get updated with every change? No. If you make changes in your comments, you have to generate it again. So do it once, make sure it works, then do it again at the end. Do we store the entire text in one string? Yes, yes we do. All right, I mean, how big can that be? The string is what, 64 bits, 2 to the power of 64. We're talking about billions here, so that should be fine, of characters. All right, yes, I said I was going to show you how to create the jar file. Export, so it's file, export. I'd actually searched for it before, so let's say I hadn't done this here. I'll simply search jar. It shows me the ones that work with that. I want an executable one. I go to next. Default settings are good. It's going to put in a subdirectory called bin. I just want to make sure it's my latest one. Okay, I had some metadata here from other things. I believe this is what I'm busy on. Okay, that was the one I had automatically. It's in my bin file. It has a decent name. Okay, don't worry about this. As long as it's the most recent configuration is in the project you're busy on, that's fine. And it was, I was just making sure. But all I did was, let me start again, file, export, search for jar, shows you the things that fulfill that name, runnable or executable jar file, next, and that's it, right? Yes, extract the required libraries into there to generate the jar, and finish. Again, some warnings because my code is not doing anything, it returns that null. Let me actually open my directory to show you that it should work. Yes, create that bin one as you saw. So I'm going to stop sharing that just for a second. All right, yes, I can do it from Eclipse, right? Well, this will work on anything, even if I'm working in a different environment. Oh, I didn't go into my practical 01. It's within my bin file there, folder. I should be able to simply say Java jar. There's my practical 1 jar. I get the same output that I got when I ran it within Eclipse, right? Once I finish my code, recreated this jar file, it should do the same thing that happens when I execute it within Eclipse. Oh, no one saw that. I was only showing you okay, this is what I was busy on. So I just opened it. Let me give it a second to show there. All right, so I happen to be right there, my top level directory of the C drive. I went into my practical 1, went into bin, and then I ran java -jar, selected that file, and there you go. It runs it and gives me the same output that I got when I was in Eclipse. All right, are we happy with those two things? All right, it's nothing new. We do it from Eclipse. The one is simply, let's go back. All right, people are happy, but now with the Java doc one, so I'll do that one more time. So we already know that for the jar file, it's file export. For Java doc, it's simply project generate Java doc. All right, the default things should be correct. Just make sure, yes, it is the correct project. If I have more than one open, I'll select the correct one. It is putting it, it'll automatically put in a subdirectory called doc. That's good. I can click finish right away. There are some other options, but those are fine. Then, is it okay if we create a batch file that runs the command code? Yes, I believe Mr. Marginal is a fan of those. So you get right to your configuration, I'm all good at that. You will simply really be, perhaps you add that to your variable, right? So you're able to execute that batch file automatically. Just make sure you're in the correct directory and that it will then run Java doc, and actually create also your jar file. Yes, you can completely do that. Right, that's already doing Eclipse. We're actually that same, those same compilers within the JRE or JSE. Right. So let's take a look. Within your main method, please redo jar. I'm getting concerned now. File, export, findable jar, next. That's it. Finish. It already exists, I'm overwriting it. That's it. Okay. It still has some issues with my methods because I'm not really doing anything. However, if I get it working, then it won't give me these errors. However, it still does create a jar file. It's just a jar file, much like my program here, just gives me a null as my output. All right, so before we get into the nitty-gritty of specific issues, I just want to go over the source files you've been given and make sure you understand what you're supposed to do. So within the main class, the first thing I do is I create a file object. I expect that my ciphertext.txt will be in the data file, a data subdirectory. It is in there if you imported it correctly. Then I want to create a string from that. So I call this method. We go to the method. Oh, it doesn't have an implementation. You have to do that. Given a file object, go into that, take all the text line by line, put it into a string, and send back that string. Okay, return that string. That's it. Very similar to what you've done last year. If you have notes on it, you are allowed to use those notes, but no sharing code, no copying from the internet. All right. Then, yes, definitely you have to do exception handling. All right. You can just print the stack, or more usefully, you can say, okay, there wasn't a file or something, so you can see exactly what's going on. But you have to do exception handling when you're doing something that can throw an exception. In fact, you will get a warning that it can throw an exception that you aren't handling it. Even if all you do in your catch is simply catch any type of exception and do nothing, but usually we'll print the stack or give some useful output to our user. All right, so that's it for the main method. What's going on within our decryptor? Note I've created a class here. All it does is store a tuple. So a pair, the first of which is a character, the second of which is a double. So it's for storing frequencies. So you'll store A 0.5 if A came up half the time, which is unrealistic that you get an A for every other letter within text. B 0.1. So every 10th letter seems to be a B, and so forth. It's just a way of storing that in a single data type that allows us to be able to compare them. And it has to implement comparable that allows us to be able, already forces that you have defined the compare to data type, which allows you to be able to compare to objects. When you define that compare to, it only looks at the rank of these tuples, those are the frequencies, and sorts the tuples according to that. So as long as you understand how that works, that allows us to have a tuple, so something that looks like this. And it looks like a character and a frequency, any double, and it allows us to be able to compare, is it less than or equal to what is it, to something like B 0.3, and it would say that this tuple is greater than that one because this one has a larger frequency or rank. All right. That's way too big. Okay, let me just see what is actually being shown here. As you can see, what, if you can see that a little better, so I've magnified the screen and then zoomed in on that a bit. So the class I'm talking about is this one that stores the character and the frequency. This compare to allows you to be able to compare two of them. And it simply looks at their ranks, and whichever one has the larger rank is considered to be the larger tuple. All right, that's something you're going to use. You don't need to do anything there. Again, I've given characters from the English alphabet in descending order of frequency. So this is that information that we get from Wikipedia and some other studies that have been done. This is the English characters, English alphabet by frequency. So that's a constant here. Another constant declared is the alphabet length. So if we want to work with a different alphabet, all we do is we change this and also change the alphabet length. Then you have to create, all right, I already filled this in to fix an error, but you're supposed to create constructors, at least the default one and one that takes a string and a character. A character array. Then, okay, for some reason I'm not getting the audio from Discord, so I'm just going to go back and forth to make sure, sorry, from Blackboard, I'm just going to go back and forth to make sure that I can hear or see what's being written there. All right, so that one does that. You're going to do your constructors, that should be straightforward. So the first method that actually wants you to do something is this. Remove punctuation. Given a string, you need to return a string without the punctuation. It's a static method that belongs to the class, so it means you can actually use it as a helper method. So I could actually, given any string, call decryptor dot remove punctuation and remove the punctuation from a string. So that doesn't actually require us to create an object of this type. So you can actually go and implement this and test it right away. All right, that makes this an independent method. You remember our testing strategies, top down and bottom up. If we're going bottom up, we're going to go to those independent methods, implement them, and test that they work. So that's something you can do right away. Then the next one, which also counts for a good amount of marks, is given a string, right, and it will be a clean string because we'll call this after remove punctuation, but actually doesn't matter what's in it. You're simply going to be counting the frequencies of English letters. So you will count how many A's, how many B's, how many C's, how many D's, assuming everything is lowercase. All right. So these two, which actually give you a significant amount of marks, they're 15 out of the 30 marks. If I go back to my main, there are 5 marks here. There are, why did that disappear? There are another 5 marks for correctness, and there are 10 marks for Java doc and the jar file. So you can already get 35 out of 60. So you can already get a passing mark for this by just implementing the 3 methods that are kind of independent of the task that we're doing. Be able to read a file, be able to read a text file and turn it into a string, be able to remove the punctuation from a string, and be able to calculate the frequency of English letters within a given string. All right, so up to there, it should be straightforward. All right, I just got a question there. Do we need to subject the frequencies to decimal precision since Wikipedia uses 1 decimal place? Leave them as, you don't have to truncate them, so leave them as the doubles that you get. Those will be more precise than what you have in Wikipedia. All right, if you were working out your own frequencies from a given plain text English text, then you would actually keep them as the highest precision you can, so you can get a more specific order and that you wouldn't get those ones that are equal. So just keep it as is, don't truncate them, that'll make it easier for you. We're asked to explain the calc frequency function again, I'll do that. Do you need to handle a case where the text is not a character? Ignore that. All right, well, you've already removed, or at least in our ordering, we will remove the punctuation first. However, if we simply want the frequencies as A to Z, then anything that is not A to Z will not increase the frequencies of any of those. Make sense? All right. Well, let's continue. I will do our prac, will end, then we do our practical, and then we do our prac, and I will extend the time accordingly. All right. So thus far, we have been able to read in the string, be able to remove the punctuation from it. Oh, and in fact, if you add the constructors, another 5 marks, that's already 40 marks out of the 60. Then we get to, great, I'm able to, given a string, return an array of doubles that represent the frequencies. Can I then calculate the relative frequencies? Right? I have the static one here. I also have one that will simply use that one to be able to calculate the frequencies of my particular text within this object. So that's when you actually create an object. So as long as this one works, then you should be able to use it for this one. This one calculates the frequencies. This one calculates, sorts it by frequencies. Oh, okay, this is not great. That's not what that was supposed to be. This is supposed to be relative frequencies of those letters. Okay, so just note, I will change this and upload it again, but this should actually be calculating the relative frequencies given the frequencies here. All right, I'll change that. Then, given the frequencies, sort our array of char frequencies by those frequencies. You've already actually been given the method to do that, so that's not for many marks. And then to compute your cipher, so to actually compute what was the permutation. A very easy way to do that is, well, we know what the regular order is for the English language, E, T, A, and so forth. If I take the 130, the one that I've sorted for my cipher, perhaps like X, Y, whatever it may be, then I know that A was mapped to, sorry, E was mapped to X. The second most one, T, was mapped to whatever was the second highest in my cipher, and so on. That will then return a or that will change my cipher here to a permutation of characters of those letters. So it'll tell me where I'm mapping my A's to, where I'm mapping my B's to, where I'm mapping my C's to, and so forth. All right. Then you can actually decipher, or once you have an array that tells you what's being mapped to what, just go and undo that. So if A is being mapped to, so if E was being mapped to X, go and find X and replace that with E. Be wary of using methods like replace all, because you may end up double replacing. So you replaced E with X. Now you go and try to replace all the X's, you end up double replacing. So rather go character by character and replace it according to the cipher. Then you have to overwrite the toString, which is simply print out your information in this format, ciphertext, colon, then your ciphertext, clear text, colon, then your clear text. So my advice would be, go and do the main method first. So go and do the method that reads the file and turns it as a string. Go and do constructors, go and do the static methods, do the toString, and then given time, do the other ones. Because those are actually completely independent of the others, and you use those to do the rest. All right. Now we'll go to the questions. All right, repeat the decipher. All right, so the cipher, let me go back to my code here. I have my clear text, right? That's simply storing the clear text that was given, that was passed to me when I create an object of this type. No, sorry, no, the ciphertext what I store when I create a object of this type. The clear text sort is this sort that I'm given here. My cipher will then be a permutation, so it'll be what are each of these mapped to. So it'll simply be the relative frequencies of my ciphertext. All right, so perhaps in my ciphertext I end up with this. I end up with, should be lowercase, something like Y. Wow. So I end up with something like this. Then I know that E was mapped to X, T was mapped to Y, A was mapped to U, and all I did was take my ciphertext, find the relative frequencies, or first find the frequencies, so the occurrences, then find the relative frequencies by dividing that by the number of occurrences, then sorting it. When I sort it, this is what I end up with. Now I know this is what the normal frequencies are, sorted in descending order. So my frequencies sorted in descending order must be what each of these have been mapped to. Make sense? So that will actually be my cipher. I am then able to say, well, wherever I find an X in my ciphertext, replace that with an E. Wherever I find a Y in my ciphertext, replace that with a T. Wherever I find a U, replace that with an A, and so forth. That will give me my clear text. All right. So when we're saying actually find out what your cipher is, it's find out what that permutation is. Find out what this is. And what is that? That is simply your occurrences changed to relative frequencies sorted by in descending order by the relative frequencies. How do you do that? Well, we have a type that can store a character and a frequency and sort according to that frequency. Right. The mapping, the cipher is there. Okay, so once you have that cipher, what is the mapping? Mapping is saying take X, put E. For every Y, put P. For every U, put A. That's deciphering it. Can we be sure that every letter is given in the text? Interesting. Then you'd simply have that the occurrence number would be 0. So your frequency then becomes 0. And so it ends up at the tail end of your cipher, so of that permutation, and that's fine. Okay, perhaps X doesn't come up. Then, can I reiterate the dividing part? Certainly. If we've, here, to calculate the rates of frequencies, we actually have to do two things. We have to count up the recurrences. That'll give me an array of, or integers. Then if I take that array, which I could have stored in double just for convenience, I sum up the values in my array, then I divide every element by the sum. That gives me the rates of frequencies. All right, and any more on that would be giving it away. Okay, so I will stay for questions, but I'll take this as the official start time. So I will change what we have on Eve there, because we have covered all that's required and then some. All right, so you'll see that now the prac has to be in by 6. You have your 4 hours. It won't be as much next time, but we are trying to get you back in the swing of things. So certainly 4 hours is fair. Try to apply the approaches that we've discussed, right? If you want to test methods, then you should do so either by starting top down. So look at the calling functions. For each method that's called, try to replace the methods that it calls by stubs, so by types that would be returned. Then try to make that method work. Then you can go into the method that it calls. So replace it with the call, go to the call and fix that. All right. Other way around, start at the bottom, look at all the methods that don't call any other methods, make sure they work, implement them and test them. So those static methods and your read file methods, read text file fully, implement those, make sure they work. Implement your toString, that should be straightforward. Implement your constructors, and then you can look at the other ones. Granted, they're also simple, but they require some understanding as to what operations are being done on which instance variables. All right, please upload so we can complete it. It is uploaded, right? The practical is already up. In additional files, that's how they read the prac, read the description of the prac. In additional files is a zip file named files. You will extract that. You will rename the top level directory what you want your practical to be called. You will import that. Oh, I just realized I don't have to update it. I was thinking of the two operations that have to be done within the calc frequencies. So I was thinking, oh, it's calculate counts then frequencies, but that is actually given that that's for 10 marks. It's a single method. You're going to calculate the counts, then the frequencies, given a string. Make sense? The other one is void because it simply updates the instance variable. The static one, given a string, I'm going to calculate, well, I'm going to take an array of type double, and I'm going to put in, well, it has to be at least of size 26, and I put in what the counts are for all the rest of the alphabet. So the first one, whatever I decide to call that array of doubles, let's say I call it D. D0 will have the count of the A's that occur within that string. D1 a count of the B's, D2, a count of the C's. Then I simply sum up all those counts and divide each element by that sum. That gives me a relative frequency. So please do both in that single method. Figure out the counts, then divide the counts by the sum to get the frequency. All right. So please don't just jump into it head first. Find out what it is that you want to do first, and then do what is simplest first and move on to the ones that require those methods that you've already implemented. That means you can test as you go along. And that's a lot more useful than simply writing out a whole bunch of code and in the end, not being able to get the marks for your jar file and for code that is complete and executes. So the void method just assigns a value to the variable C frequency. Exactly that. Exactly that. Then can you please type it down somewhere so you can remember the statement of counts and divisions? No, I shouldn't even have told you how to do it. So I'm certainly not going to write that down for you, right? You should, from your own understanding, be able to decide what the operations are. If I simply give you pseudocode and ask you to do those operations, then you're not actually solving a problem. You're converting pseudocode to code. I am helping you get started this time, right? Ordinarily, you'd simply have the descriptions. So what you have in your comments above each method you have to complete, and you should use your understanding of that together with what are the parameters, what are the return types to decide what you should do. All right, so I shouldn't use the calc-my frequencies. No, you should use it. What I mean is that if you have calc frequencies, the static method, this helper method, then an instance of this class can simply call that to calculate its frequency, right? It has its ciphertext string. It can pass that, find out what the frequencies of that are, and store that in its ciphertext frequency. All right, so Mr. Bodila, who couldn't hear, could you just tell me what it is you want to hear or what it is that you missed, and I'll repeat that. All right, so does remove punctuation, remove the spaces too? You can if you want. Because you are simply trying to figure out the occurrences and then the frequencies of the letters, you don't need to worry about spaces. So I consider each character. If it's not a letter, should I increase the count of any letter? No. All right. I will simply end up with a permutation of my letters that I can then apply to my original encrypted string, ignoring punctuation, ignoring spaces, and simply mapping encrypted characters to the previous characters. The frequencies allow me to determine the order. That's all. I sort my frequencies, I find out the frequencies and sort by them to find out what has been swapped with what. I know E should come first because E has the greatest frequency. If I figure out my frequencies and sort by frequencies, and I find that X comes first, then E was mapped onto X. My decrypt should map X onto E. Which method do you say we must calculate the number of characters in text? To be able to calculate the frequencies in the string, you must figure out the counts, then the sum of the counts, then the frequencies. All right, so it is calc frequencies of a string. And even if the method names aren't that explicit, look at the comments. Calculates relative frequencies of letters in a given string. Your parameter is S, which is a string, and the return type is an array of frequency. So even if you understand nothing else about the larger project, you should be able to implement that method by understanding that comment. I'm given a string, I want to figure out the relative frequencies of the letters. I can do that, right? I can count up the letters, I can divide by the sum, I can send back the frequencies. Do we have to use Eclipse? I'm concerned because that implies you weren't in class. No, you don't have to use Eclipse. but I have to be able to import it to Eclipse. All right, much like how I did now. If I'm able to say file, open project and directory, which means it has to be a directory that has some top level directory, there'll be the name of my project. And then within that, a source file, so a folder with source files in it, and a data folder with data files in it. And that is enough. Yes, certainly, please do. You are free to leave. As I said, the batch officially started at 2. You can stay if you have specific questions. To make it fair for all, I'll actually go on to Discord now and answer questions there so that you're all encouraged to go and actually do it now. Please upload the update. I'll reiterate, there isn't an update. I simply misspoke when I said that it has to be 2 different methods. Those 2 operations are combined into a single method. Calc frequencies has to calculate the counts, then the frequencies. All right. If you're feeling gutsy, yes, use Notepad. At least use Notepad++ so that it highlights, keywords and all that. Doesn't Eclipse automatically create a jar file? You can create it in 3 clicks. So there's no update, yes. Right, originally I had planned to have it as 2 methods. However, I combined it into 1, and that's why it's out of 10. When you run the project, no, it creates class files, which are then run. But that you learned a long time ago. JavaC creates class files from your .java files. Then you can use Java to run those class files. Yes, those class files. All right, thank you and good luck. If you are strategic about it, you'll have no issue. At the very least, you'll get the 40. Then you can spend your time applying your mind and trying to get those extra 20. All right, but it's not trying to trick you in any way. It's can you, given some data and a description of what you should do with it, actually go ahead and do that.